Find the percent of sand in the soil. In this problem, we've been provided the results from a sieve analysis test, where the sieves are ordered from largest opening to smallest opening. Assuming cobbles, boulders, and larger rocks are not present, we define gravel as all particles whose smallest diameter is greater than 4.75 millimeters. Sand is defined as particles which range between 0.075 millimeters and 4.75 millimeters, and fines are all particles smaller than 0.075 millimeters. Next, we add a column to show the size of each sieve. All the gravel will collect on the number 4 sieve, and all the sand will pass by the number 4 sieve, but won't reach the pan. In other words, we can draw lines between the sieve sizes and identify which soil type will be retained on each sieve. Next, we sum the mass of the soil retained on all sieves, which is 850 grams. After that, we compute the total mass of soil retained for each of the 3 soil types and compute their percentages. For example, out of the 850 gram sample, 145 grams of that was gravel. On a percentage basis, 145 grams is divided by 850 grams, and we have 17.1% gravel in the sample. 677 grams of the sample is sand. This computes to 79.6% of the entire sample. And lastly, 28 grams of fine grain material results in 3.3% of the entire sample. Since we're looking for the percentage of sand in the soil, we note the percentage is most nearly 79.6%. Upon reviewing the possible solutions, the answer is C. This solution can also be determined if only a plot is provided in the problem statement. Let's see how this data would plot. Grain size distributions plot the sieve size on the horizontal axis on a logarithmic scale by the cumulative percent of the mass passing each sieve on the vertical axis using a linear scale, which we will now calculate. We first look at the mass retained on each individual sieve and calculate the individual percentages by dividing by 850 grams. The last column shows us the percent mass of the soil sample retained on each sieve. Remember, we're trying to determine the cumulative percent of soil passing each sieve. So let's start a new table and copy over the 2 columns in red, the size and the percent retained. A cumulative percent retained column is added to sum the percent retained from each sieve, including the percent retained from all larger sieves. For the largest sieve size, the cumulative percent retained equals the percent retained for that sieve alone. But for the number 10 sieve, the cumulative percent retained is the 24.3% from the number 10 sieve plus the 17.1% from the number 4 sieve above it. This process continues as the cumulative percent retained values approach 100%. Next, we add a column for the cumulative percent of mass passing each sieve, which is simply 100% minus the cumulative percent of mass retained on each sieve. For our first sieve, the cumulative percent retained is 17.1%. So the cumulative percent passing is 82.9%. This calculation is repeated for the remaining sieves. We preserve the data we need for the plot, namely the sieve size and the cumulative percent passing. The semi-log plot is set, and we plot our points for the number 4 sieve, the number 10, 20, 40, 100, and 200. A line is drawn to connect the data points. The original question asks us to find the percent of sand in the soil. So, we divide the plot into the three identified soil types by identifying the boundary between the gravel and sand at 4.75 millimeters and the boundary between the fines and sands at 0.075 millimeters. Sketching up to the line and then over to the cumulative percent passing axis, we identify the gravel is 17.1% of the entire sample, the sand is 79.6% of the entire sample, and the fines is 3.3% of the entire sample. Returning to our possible solutions, the answer is C.